Okay, so we're back to Cody and his boat here. As you recall, they left at noon. At 1 o'clock, he was 5 miles east and 12 miles north of when he started at 1. By 2 o'clock, there's 2 p.m. He's 10 miles east, 24 miles north. He's traveling, let's go back down here, a total of 13 miles in that first hour, and the second hour too, for a speed of 13 miles per hour. We calculated all this earlier. We're tossing some extra information. He has 17. Well, he's just going to go until he runs out of gas, and he's going to call for help. His tank holds 17 gallons. He gets 5 miles per gallon. So we got to figure out how far he runs before he runs out of gas. Well, at 5 miles per gallon, that's 5 miles per each of these 17 gallons. He should be able to travel 5 times 17, which is 85 miles. So we just need to work out and find out, go down our distance here until we hit 85 miles, and we'll see what time that is and how far east and north he is, and we'll know his position, and we'll know what time it was when he ran out. So let's see here. At hour 3, it's 15 and 36 and 39. At hour 4, it's 20 miles east and 48 miles north and 52 miles total distance. This might take a minute, so I'll just kind of finish it up without you. Alright, so I filled out the rest of the table, and then I ran into a problem. You'll notice, after 7 hours, he's gone 35 miles east, 84 miles north, for a total of 91 miles, which I filled out the fuel used column here, and that's over 18 gallons of gas. And we already figured he could only go 85 miles, 91's too far, so it happens sometime between hour 6 and 7, but we want to be more specific than that. By the way, with the fuel used column, if you think about it, 5 to 1 mile per 5 gallons would be 2 gallons per 10, and so on. And so if I wanted to take the number, or like a 15 gallons per 3, if I wanted to find the number of miles and calculate the number of gallons, I would just divide by 5. So what I've done here is I took the number of miles, 13, and divided by 5. I wrote it as a fraction. Didn't actually figure out what it is as a decimal. It's like 2.6 or something like that. 26 divided by 5, 39 divided by 5, and so on. 90 divided by 5 would be 18. So 91 divided by 5 is a little bigger than 18. So, all right. So what I need to figure out is, where is he at 85 miles when he runs out of gas? I've skipped from 78 to 91. I went too far. Where is he at 85? Well, if you look at the patterns here in the table, the total distance is 13 times whatever the hour is. So 1 times 13, 2 times 13 is 26, 3 times 13 is 39, 4 times 13 is 52. So if I want to find out where he is, say, at any given distance, or how many hours it takes him to go any given distance, I just take that number, that distance, and divide by 13. So 78 divided by 13 is 6. 65 divided by 13 is 5. 52 divided by 13 is 4. And 85 divided by 13 will tell us what the number of hours is. Now 85 isn't divisible by 13, so what we're going to do is we're going to write that 85 over 13. I'm going to write that as a fraction for now, because we could turn it into a decimal, but it would be a really ugly repeating decimal. We're just going to leave it as a fraction for right now. So we know what time it is. It's 85 thirteenths, which, if I go on my calculator here, 85 ABC 13, 6 and 7 thirteenths. So somewhere between 6 and 7 hours, which is where we expect it to be. Now we also want to know what's his position, east and north, at this time. So what we need to do here is I know that I just take the time and I multiply by 5 to get the position east, and I multiply by 12 to get the position north. Right, so I'll just have to take this time, multiply by 5 and 12 to get these two times right here, or these two positions. So 85 over 13 times 5. And so we'll just go times 5. And I'm going to write that as an improper fraction, 425 over 13. Okay. And then we'll take 85 13ths and multiply by 12. I get 78. I'm going to turn that into an improper fraction. Notice the procedure for turning things into an improper fraction. Second, then hit the ABC button, and then just go down here and hit enter. Second ABC, enter. 1020 over 13. Okay. So 1020 over 13. So these are his positions east and north. And I also want to represent those as 78 and 6/13 as mixed numbers. So 425 over 13. Should have just written that down the first time. 32 and 9/13. Okay, and then finally, let's write those as a decimal. So 9 divided by 13 is 0.69, so we'll just call it 0.69. We'll round it off to the 2 decimal places. The 2 tells us to leave the 9 alone, so it's the nearest hundredth. So if 9/13 is 0.69, then this is 32.69, and 6/13 would be 0.46. So 6/13 is 13th is 0.46. Then this will be 78.46. Okay. So and this is all kind of one big line here. So at 85 miles when he runs out of gas, he's 78.46 miles north, 32.69 miles east. Anything else we were wondering about here? Oh, and it happened at 85/13 hours. So, let's see, 85, ABC 13, that's 6 and 7/13. So let's see, 6 and 7/13 hours. So that's kind of a funny thing, like 6 and 7/13. What time is that? So let's kind of figure that out. Well, it's going to be 6 o'clock, and we have to figure out what 7/13 of an hour is. So what we'll do is we'll go 7 divided by 13. We'll turn that into a decimal. So it's 0.53, 0.53, 0.54. And then we'll multiply that times 60 minutes in an hour. And we get 32.3 minutes. So we'll just call it 32 minutes. So this would be at time 6:32. Keeping in mind that it only translates nicely from 6 and 7/13 to 6 hours and 32 minutes, or 6:32 p.m. because he started at noon. If he'd started at some other time, we'd have to add 6 and 7/13 to the initial starting time. So again, at 6:32 p.m., he is 32.69 miles east, 78.46 miles north. He's gone a total of 85 miles and run out of gas. So then, just to sort of go over again how we did all this in general, I started out by putting all this information into a table. So, on the information we were given, So at time 0, he's 0 east, 0 north. He hasn't gone anywhere and hasn't used any fuel. We were told that at 1 hour, he's 5 miles east, 12 miles north. We used the Pythagorean theorem to calculate that he traveled 13 miles overall. And from there, we just sort of, added an extra 5 miles east and an extra 12 miles north and an extra 13 miles of total distance for every hour that he traveled. And we sort of ran the table down until we got to 7 hours, where we saw that he'd run 91 miles, which was too much. He's run out of gas at 85. So we had to kind of work back and find out where is he at exactly 85. And then we noticed that, well, to find out the number of hours from the total distance, we just divide by 13. So we took 85 and we divided by 13 to get a time, 85/13. That time, by the way, is 6 7/12, so 6 7/13. We divide 7 by 13 and then multiply by 60 to get 32 minutes. So it's 6 hours and 32 minutes since noon, which is 6:32 p.m. So we knew that at this time, 85/13, we just take that time, multiply by 5 to get the total number of miles east, and that was 425/13, which we turned into 32 9/13, which is a decimal, is 32.69 miles east. To find out how far north he was of where he started, we just take the time, 85/13, and like all these other numbers, just multiply them by 12. So that was 1020/13, which was actually is a mixed number, 78 6/13. And we turn that into a decimal, and it's 78.46 miles north. So if he wants to tell somebody where he is at 6:32, where he's floating around out of gas, he is 32.69 miles east, 78.46 miles north. I think that settles all that.